There is a type of celestial body in the universe. You cannot see it, but it truly exists. This celestial body is the black hole. Black holes are arguably one of the most mysterious celestial bodies. Its gravity is incredibly strong. So strong that it even warps the surrounding space-time. No object can escape its gravitational pull. Not even light can escape. Therefore, black holes can only be found through indirect methods. For example, when we observe a distant celestial body and find that it is orbiting an invisible gravitational source, or when it is devouring another star, creating an accretion disk, its existence can then be detected. It can be described as a whirlpool in a river. Once you get close, you will be swallowed by its powerful pull. Therefore, the escape velocity of a black hole exceeds the speed of light. If such a black hole were to enter our solar system, the consequences would be unimaginable. Its powerful gravity would disrupt the gravitational balance of the entire solar system, causing planets and satellites to be thrown out of their original orbits and collide with each other. As it approaches Earth, it would completely disrupt the asteroid belt, causing the Earth to be constantly bombarded by these asteroids. Humanity's doom would be imminent. Next, the Earth would begin to be torn apart and disintegrated by the immense gravity. The first to be stripped away would be the atmosphere. Then, the entire Earth would fall into the black hole, ultimately being completely devoured. One can only imagine how terrifying black holes are. This may lead some to ask, what exactly creates such a terrifying celestial body? How can its power be so immense? The answer is massive stars. We know that. The reason stars can burn continuously relies on internal nuclear fusion reactions. During their burning process, they will continue to fuse elements step by step until their fuel is depleted and they die. When a massive star runs out of fuel, the fusion process stops at the element iron. This is because when a supermassive star fuses elements up to iron, it can no longer release energy through nuclear fusion. Thus, the core, under its own gravity, begins to collapse. At this point, the star's core is mercilessly crushed. Electrons are forced into the atomic nuclei, combining to form neutrons. This continues until the neutrons themselves are crushed to dust. Finally, the entire star disintegrates, resulting in the universe's most powerful hypernova explosion. And at the center, A black hole from which not even light can escape is left behind. However, these are only stellar mass black holes. There are even more powerful entities in the universe, namely supermassive black holes. Scientists have discovered that supermassive black holes are generally located at the center of galaxies. For instance, there is one at the center of our Milky Way galaxy. In the beginning, people did not know that at the center of the Milky Way was a giant black hole. This is because a large amount of interstellar dust blocked our view, making it impossible to see the center of the Milky Way. It wasn't until the development of infrared telescopes that scientists were able to peer into the heart of the Milky Way. After 15 years of observation, astronomers discovered that a large number of stars in the center of the Milky Way were all orbiting an invisible source of gravity, and they were moving at extremely high speeds. So what could provide such a powerful gravitational force? The only answer is a supermassive black hole. Because the gravity of a black hole is so strong that not even light can escape. This kind of invisible gravitational source is the best proof. Thus, scientists finally confirmed that the center of the Milky Way is a supermassive black hole. And based on the trajectories of the stars, they calculated its mass to be 4 million times that of the Sun. Its Schwarzschild radius reaches 24 million kilometers, which means its diameter is about 48 million kilometers. However, our Milky Way is not the only galaxy with a black hole. Later, when astronomers observed other galaxies, they found that in the center of most galaxies, there exists such a supermassive black hole. For example, the Andromeda galaxy, the closest to Earth, has an even more massive central black hole, with a mass of 140 million times that of the Sun. Therefore, some people believe that black holes are the masters that govern the evolution of the universe. Without black holes, perhaps we would not have evolved. Whenever we, on a clear night, look up at the starry sky, we see a sky full of stars. Without the aid of a telescope, the naked eye can see over 6,000. But in fact, this is just the tip of the iceberg. Within our Milky Way, there are at least 200 billion stars. According to scientists' estimates, in the entire universe, the number of stars exceeds the total number of grains of sand on Earth. It is precisely because of them that all things were created. Among so many stars, the closest one to us is the Sun. It is a giant celestial body made of plasma. Its volume can accommodate 1.3 million Earths. and its mass is 330,000 times that of the Earth. However, although the Sun is large, it is incredibly small compared to truly massive stars. What we are looking at now is Eta Carinae. Its volume is 5 million times that of the Sun. This is Betelgeuse. Its volume is 700 million times that of the Sun. This is VY Canis Majoris. Its volume is 8 billion times that of the Sun. Although these stars vary in size, their formation process is nearly identical. They are all born in nebulae composed of gas and dust. Scientific research has found that, in a giant molecular cloud, due to the long-term effects of gravity, matter gathers together. When a high-density region appears, large amounts of the nebula will gradually collapse towards this high-density region. Due to the conservation of angular momentum, as the nebula contracts, its rotation speeds up, slowly forming a disc-like structure. And at its center, as the collapse continues, more and more matter accumulates. The temperature and pressure rise. When the core reaches 15 million degrees, the fusion of hydrogen is finally initiated. Just like that, a hot star is born. Next, it will continue to burn stably. Depending on its mass, some may burn for billions of years, while others may last for tens of billions of years. At this point, many people may have a question. Why do stars burn for so long? Where does their energy come from? The answer lies in its core. Taking the Sun as an example, the reason the Sun can burn continuously is because a continuous thermonuclear reaction is happening in the Sun's core, where 4 hydrogen atoms fuse into 1 helium atom. Every second, about 600 million tons of hydrogen are converted into 596 million tons of helium, releasing the energy equivalent of 4 million tons of hydrogen. It is this energy from fusion that brings light and heat to the Earth. However, the Sun will not continue to fuse elements forever. When its fuel is exhausted, it will come to an end. It is estimated that in about 4 billion years, the Sun's hydrogen will be gradually depleted. Internal fusion will slow down. At this point, gravity will begin to take over. The core's energy will be insufficient to maintain hydrostatic equilibrium. Its volume will expand 200-fold, turning it into a giant red star. At that time, the Earth will be directly engulfed by the red giant. During the red giant phase, the Sun's core will begin to trigger a new round of nuclear fusion, namely, the process of fusing helium into carbon. However, the conditions for carbon fusion are extremely high. When the sun's core is completely transformed into a carbon ball, it can no longer continue to fuse and release energy. Eventually, the entire star will disintegrate. Its matter will be ejected outwards, forming a planetary nebula. At the center, only a high-density white dwarf will remain. And if a star's mass is much greater than the sun's, its death process will be even more spectacular. It will also create the building blocks of life. For example, Betelgeuse, 640 light-years away, is a star much larger than the sun. Its mass is about 15 times that of the sun. The nuclear reactions inside it are extremely violent, capable of fusing elements up to iron. The moment of its death is completely different from the sun's. It will result in a supernova explosion. This is the most violent astronomical phenomenon in the universe. The energy released in a few seconds is equivalent to the total energy the sun will release in its entire lifetime. After it dies, what's left of the core is an even denser neutron star. If it is an even more massive star, with a core exceeding 3.2 times the mass of the sun, then it will form a black hole from which not even light can escape. Moreover, in the moment of their violent explosion, massive stars can also create heavier elements, such as precious materials like gold and silver, and even the elements of life. It can be said that without supernova explosions, there would be no you and no me. Therefore, we are all products of the stars. So we should be thankful to the stars for endowing the universe with the elements of life. Whenever we look up at the moon at night, we will notice a phenomenon. That is, the moon always keeps the same face towards the Earth. Today we know this is actually due to the moon's rotation period being the same as its orbital period. That is, for one complete orbit around the Earth. The moon also rotates exactly once on its axis. Therefore, only one side of the moon ever faces us. This phenomenon is called tidal locking. Tidal locking means we can never see the far side of the moon. This also makes us curious about the far side of the moon. What is on its far side? What exactly is there? Hello everyone. This is Space Science Station. Welcome to this episode. On October 4th, 1959, the Soviet Union launched the Luna 3 probe to the far side of the moon. This was the first human probe to go to the far side of the moon. On October 7th, 1959, as Luna 3 flew past the far side of the moon, it sent back 29 images. For the first time, humanity saw the appearance of the far side of the moon. However, due to the technological limitations of the time, the resolution of the photos was very low. On December 21, 1968, the United States launched the Apollo 8 spacecraft on a lunar orbit mission. After a 6-day flight, the 3 astronauts successfully reached the moon and began to orbit it. This time, humans witnessed the far side of the moon with their own eyes and discovered that the far side of the moon is densely covered with craters, a huge difference from the near side. As a result, scientists had a new question. Why does the far side of the moon have more craters than the near side? To understand the answer, we need to go back to the origin of the moon. According to scientists' speculation, about 4 billion years ago, a Mars-sized planet collided with the Earth. In the violent impact, this planet was almost completely destroyed, sending a large amount of debris into space. However, this debris did not escape Earth's gravitational field, but instead gathered in orbit around the Earth and then formed the primordial moon. In the early stages, the surfaces of both the moon and the Earth were almost entirely molten rock, and they were constantly bombarded by meteoroid fragments. However, as time went by, after the moon was gradually tidally locked by the Earth, its near side, due to continuous high-temperature radiation from Earth, meant the side of the moon facing the Earth remained in a high-temperature state, while the far side of the moon, without the influence of Earth's high temperature, the molten rock quickly cooled and solidified. Therefore, when meteorites repeatedly struck the solid surface of the moon's far side, they left behind a dense field of craters. As for the near side, because it was molten rock, after being struck by meteorites, it didn't leave many traces. If someone asks you what the Milky Way looks like, you would probably answer that it is a flat, barred spiral galaxy with a diameter of about 160,000 light-years. But have you ever thought about another question? We haven't even flown out of the solar system. So how do we know what the Milky Way looks like? As the saying goes, you can't see the true face of the mountain because you are in the mountain itself. In fact, everything we see, all the panoramic images of the Milky Way, are not actual pictures of the Milky Way. They are simulations created by scientists based on observations. Because we are inside the Milky Way, it is impossible to see a true panorama of the galaxy, unless we leave the Milky Way and travel to a much more distant location. But with current technology, that is simply not possible. Therefore, to know the full picture of the Milky Way, scientists need to observe a large number of other stars in the galaxy, then measure the distance and position of these celestial bodies relative to Earth. After collecting data on these celestial bodies, this data is then fed into a computer to simulate a panorama of the Milky Way. From this, we can roughly determine the main structure of the Milky Way By observing the distance, position, and velocity of other stars, we can not only know the general structure of the Milky Way, but also infer our position within the galaxy and how we are moving. According to current observations, our Milky Way is a barred spiral galaxy, forming a flattened disk structure, and it has 4 distinct spiral arms. And the solar system is located in the outer regions of the galaxy, in an arm called the Orion Arm, about 26,000 light-years from the galactic center. We are currently moving at a speed of 230 kilometers per second, orbiting the galactic center. In about 8 days, we travel 150 million kilometers. It takes 1,400 years to travel 1 light-year, and it takes 250 million years to orbit the galactic center once. However, these data are not completely accurate, because with new discoveries, the structure of the Milky Way is constantly being revised. In 2015, scientists' research found that the Milky Way is actually more than 50% larger than previously thought. Therefore, the diameter of the Milky Way was also revised from the previous 100,000 light-years to what is now believed to be between 160,000 and 180,000 light-years. Thank you for watching the Space Lens, exploring the mysteries of the universe. If you enjoyed this video, don't forget to like and subscribe to join us on the next journey through space. Thank you for watching the Space Lens, exploring the mysteries of the universe. If you enjoyed this video, don't forget to like and subscribe to join us on the next journey through space.